So it's about small containers. Small containers sometimes help, sometimes they don't, but we'll discuss important cases, then it is a real help. As you know, my name is Dmitry Chuyko. I used to work at Oracle Java organization, and now I work at a company named BellSoft. Excuse me just a moment. Is the next slide visible, clear? There should be my photo, and if I can get any technical feedback on that. I guess it should be visible. All right. So the company releases and supports its own binary of OpenJDK. It's called Liberica JDK, and we are among top contributors in OpenJDK community. You see here both two latest LTS releases. Then the company already existed, JDK 11 and JDK 17. And we do it to help developers close their needs from the runtime to have the runtime that is safe, that is effective in some senses. And of course, it works in production. And then we build our production, we deploy our business logic, our business code as something. Previously, we used maybe jar files, war files. Now we still use them, but we hide it from the overall cluster software because we just ship containers, right? It is very effective. It is very easy. In a very simple case, we can just compress our container image and transfer it over the, I don't know, USB flash key or the email or some drive in public cloud. It's really possible. It's just an archive with a simple structure and metadata. Nothing, no real black magic here, right? And what we do, of course, is not transferring it via USB flash key, but rather using some registry and transferring our container images over the network. Then from that registry, we deploy it to our actual prod environments or some CI systems, maybe staging. And that registry can be located in different places, in different networks. It may be owned by different parties. It may be owned by us. There may be actually few registries that exchange data. And we combine layers, typically, right, to cache some base functionality that's required for upper layers of the final container image. So then we exchange the data over the network. Of course, that cases are rather obvious, but still we can discuss them to make it slightly more clear. It may be some registry located in a third-party cloud or just provided as a service or with other means. And then our network where we develop some functionality, it is one network. Then there is a network and isolated with some means environment where registry lives. And then there is a production network where we consume the final image. And they may be split in different ways. So we may have a registry instance in our development network. That's quite possible. As I said, it may be a third-party one. It may be a SaaS in the same cloud where our production lives. That's quite easy to start from scratch, right? We just used everything from our cloud provider. It may be a third-party registry where we upload it, and then there may be a mirror. In particular case, it may be a trusted registry, right? If we consume different base images in our own layers inside our trusted network, we consume trusted base layers from trusted registry, and then we build our final image inside our isolated environment. It may be some business critical functionality, maybe banking or some other cases. So when we collect all this together, what happens? You know that now there is no such thing as a fully free registry for your container images. Even Docker Hub, that used to be like no limit free storage for your containers, now charges you if you want unlimited plan. If you use some SaaS, you anyway pay for something. Like, for example, you pay for cross-region traffic, or you may pay for everything for storage. And storage will be like not just how much do you store, but also how long do you store. And then if you maintain your own instance, of course, it costs you time of your maintainer persons. It won't be free. Someone has to do the actual work. Again, even if you have internal registry, you still have to manage your traffic. Sometimes it's not so obvious. Then, sometimes it's easier. For example, your traffic may look free if it goes between something close, some close nodes in that or this sense, like in the same region in public cloud, or maybe in the same data center in your on-prem solution. If you waste CPU time, it always costs you. It is time, and it is time of some machine that's not free and possibly not cheap. And of course, if you manage it yourself, you more likely have some downtime, outages, and that is not so pleasant. So here, small images probably can help. Why? Because they require less storage. They have weaker traffic requirements, right? Because they're small. But small doesn't mean ineffective. So small images are like TARDIS. They are small from the outside, but much more functional inside. And then we talk about that images. The especially important case is working with base images. There's some parent images. I interchange the terms, but more strictly, a base image is something that starts from scratch, and a parent is just a parent. But in the world of JVM and JDK, parent image with JDK is the base image. So the final resulting container will consist of a very thin top layer with your application, and then something more heavyweight, your framework, your libraries, your operating system packages required, for example, optionally for your JNI enabled native code that interacts with your JVM based application. And you of course have some runtime, required packages to run that runtime, and base packages of the operating system. That's the very baseline. How do we build that container? Well, we repeated that questionnaire this year. It's more or less the same, except as expected, now more people use tools and more people use containers. So still, it is unexpectedly popular to use deployment without any containerization, but not because it is liked by developers, but because they have to do it. And of course, then we talk about containers. Still, it is a preferred way to create a container image by hand. It's not, well, exactly literally by hand, because of course you use all the tooling that, for example, Docker provides you, or other means of assembling the container, and it can be performed automatically by your build system plugins or by some other tools. It's also popular. And if you use cloud native build packs, for example, it's all performed by Spring Boot plugin that does that, if you use Spring Boot. Then our goal, as you remember, is to make the container smaller. Is it possible? Yes. We can split our application into smaller services, right? That will make their containers smaller. You can try to select your framework or your libraries based on that, based on its size. And of course, the great option is to reduce your OS layer, to reduce your packages requirements. Again, if you split the application, you need probably less packages if you need them, or you select a very minimal base OS. So how do we select something? Well, we have to choose the main criteria to do that. It may be not just size. Most likely it will be performance. It may be an option to have commercial support, to get fixes real quickly, to get SLAs. It may be correctness in the sense of meeting some standard requirements. There are multiple great standards, and we'll mention a few of them. It is important, really. And if we talk about size and support, there are multiple comparisons that you can meet. And size is very different. If we look for a moment at the other side of the coin, there will always be Java runtime. And Java runtime also can be made smaller. And we still have to select the right amount of how small it will be. Like we can select, for example, a minimal VM. It is very small, but it will have different performance, right? That's something probably more suitable for embedded devices, not for like cloud deployments, but still it is an option. And again, this runtime works and requires some operating system, some distribution. It may work in so-called distroless environment, which is not actually distroless. This is some distro without package manager and shell functionality. So it's like ripped off distro, package managerless. So let's study what do we have out of the box. We have some container images suitable as to be base images, right? It's not that complex to measure their size. And we'll start with a simple image called OpenJDK. Who knows what is this? Please be curious and study different versions of this image. You'll be very surprised. And okay, we'll enable some diagnostic features and look inside. Well, we'll see that then it was transferred. The transfer was like a quarter of a gigabyte, plus or minus depending on version. Sometimes it's like 220, sometimes this is for the latest 17, 232 megabytes. And then it's uncompressed, it's almost half of gigabyte on disk. It can be easily discovered, it's not a secret. For some less recent versions, it's slightly older than 500 megabytes. And that's a lot, right? We need some runtime, which is, yes, it is sophisticated, but it must not be so large. What's worse, if we perform that operation, getting it on some clean host, or we update our containers to have the last and secure version of JDK, we'll have a very long pull time. So if our network is not gigabit one, well, we have to wait like half a minute, or if it's like 10 megabits, it will be much longer. To me, it sounds unacceptable. And yes, if it happens somewhere, and somewhere maybe a public cloud, we'll be charged for everything, like for storing the data, for transferring it over the network, for some CPU during uncompress and all the things. And so we work for that half of a minute. It's probably around zero, but still, if you do it often, then it costs something. And we have to store it in the registry, or to use the registry where we consume it. Sometimes it may be free, sometimes it's not. And one case easily turns into another, you know. That's the point of making it free and not free at the same time. And you get high from hell. You get your bill for something that you assume to be completely free. And even worse, then you have D-Day in your production, you deploy a lot or you update a lot, you have very high traffic in a very limited time flying over your internal connections. That may break some of limits. You may unexpectedly meet limit for your disk because you can share something on some instances. So it's a pain. It's not something they want to see, or at least they won't see it very frequently. Then the combine OS and JDK, we must test. We must test the final combination or provider that does that, right? So we can be in one head provider, and another head it will be a consumer, some developer. So your final base image must be tested, compatibility must be ensured, compatibility of OS and JDK, compatibility of JDK to JavaC standard, and the way that they are combined may be different. Two most typical ways are, then you look inside how your Docker file is structured. Will probably be using some binary consumed via the API, or some stable download links or unstable download links. And another way, of course, is installing package. The package may be located in default OS repository, or it may be located in some external OS repository plugged in from the outside. Anyway, they must be compatible. Looking at the base OS layer, you will find that it may be very, very different. And in terms of size may vary 10 times or 20 times, which is a lot. And still there is a champion here. A distro called Alpine Linux, which is less than 3 megabytes, then you send the container image over the wire. And it still has standard C library. It has package manager. and it has shell. You see, it's not a typical C library like most of other examples here, and it's not a typical shell. And the package manager probably is not the one that you're very familiar with, but still it is fully functional. And by the way, it is even smaller than an image called distroless. If you include C library there, still no shell, no package manager, it's distroless. It will be larger than Alpine. That makes it so unique. And then we use that Alpine image as a base to build the resulting base image. The wire transfer size will be like 70 or 71 megabytes. And the size on disk will be less than 100 megabytes. That's much smaller than the original experiment, right? Here, both two parties are optimized, the OS layer and the JDK. JDK is so-called JDK Lite, which is still fully compatible to Java specification. It contains everything it must contain, but it's slightly optimized to be smaller, still having the same performance. And it's used in all images listed here, and they are all small, you see. Then you pull that image. It will be fast as a Blaze or as TARDIS. It will take only 4 seconds on the same network. And it's an interactive action. So small containers really help here. Well, there are some questions. What's inside? Something not very known, but we'll look at this Alpine Linux in some detail. It's a great tool. It is a Linux distro designed to be lightweight, to be secure, and it's based on two key things, musl and Busybox. Let's look what they are. So musl is an implementation of standard C library. Why do we ever need C library? Because HotSpot is a C++ program. So it requires some base functions to be there for, like, if we talk about Linux, some POSIX, standard POSIX functions to use actual kernel functionality, to use operating system functionality. And that's what musl does. It tries as much as it can just wrap the standard kernel calls, wrap syscalls to provide standard functions. It also implements some widely agreed extensions, but not some extensions provided by glibc. It is small. It has free license, and it tries to cover the standard, because sometimes it may be not the goal. Some C library implementations may say, okay, we have different targets. We implement this part of the standard because it is important for the targets, and the other part of standard may be not implemented. The code there is also great to read or to fix because it's simple. If something can be done in a more simple way, or something can consume less memory, that is the preferred way in musl. It also has some nice features, like because you have compact structures describing your stacks, and you have many of them, that means great scalability. And also the code inside is written in a defensive manner, that means better security. And this is assembled as a single binary, and it supports UTF-8 out of the box. So it is a very kind of production use thing. how it is compared to other libc implementations? Well, there are numerous implementations of standard C library, and people did compare them. This is just an example, some probably outdated data that was collected at times. Then musl was actively fixed and was really unknown. So what criteria are important here? A lot of things. You see, the interesting is color. So like having more green is better, of course. But there may be a performance comparison, different behavior in cases where standard does not define this behavior, right? It may be more secure or less secure, like what's expected by user. And popular implementations are very different in size, and they're different in what they have in terms of green and red here, right? Like UTF, different platforms. For Java, for example, it is important to have as many platforms as possible, because Java itself has many platforms. So if we are able to use that small library on different platforms, that's great. And also standard compatibility. So you see POSIX here, which is really important, and musl is really good from the perspective of such comparison. No like no performance loss in any known common cases. We'll have some interesting studies on what can be improved, and we even have some interesting implementations of how it can be improved, but that's not the topic of this talk in particular. Yeah, as I mentioned, there are many platforms where musl is present, including the popular platforms for OpenJDK, the platforms that are part of default main branch of OpenJDK. So you see that that's comparison that you can do by your own, and that's done by many people constantly, and that makes us sure that that's the technology we can use as the key technology inside our user space on Linux, and in particular musl. Yeah, as I said, HotSpot is a C++ program, and if you open the main starting header or starting implementation file for Linux, you'll find that it includes standard library headers, right? So we do need that standard library. Another key component of musl is Busybox. Of Alpine Linux is Busybox. It is a Swiss Army knife tool, a single binary that pretends to be a different Linux or Unix programs. So we have symbolic links to the same program, and it realizes which link was called and acts as the program that was called. What it gives us, great code reuse, like we share everything, we share same binary doing multiple tasks. That saves us footprint, and we don't need to reload it. So it's quite effective. We share the code inside, and it's even available, of course, on other platforms like Android, for example. You can drop a Busybox binary there in the root environment and do something. Sometimes it may be not so familiar. Then you work with a single binary, or you work with an implementation that conforms standards but is slightly different from the implementations in operating systems you used to. But that's still okay, right? as soon as we conform standards and we are fast and memory effective, that's great. You have just to develop some habit of using Alpine environment. So you have that ash flavor of Busybox to have in the shell. And there's also an init system, which is just lightweight. The start of bare metal installation of such operating system is quite fast, and the start of container is quite fast. And user space binaries in Alpine Linux are compiled with stack protection, stack smashing protection. That's again about security of your deployments. So we saw that this system is really suitable for our needs, right? It's slightly different, not something we will use on the desktop, but still it's very convenient, and it has package repository, and it has that package manager, so we can install necessary tools or necessary libraries. So, is it perfect for containers? It looks like it is. It is small, it is secure, it contains many tools. So how about combining it with Java runtime? It required porting the Java runtime to the Alpine Linux. Because that's a different standard C library. As I mentioned, not all the functions that is there on glibc and that are used by HotSpot are there. So there was a project called Portola, and there was a job implemented by BellSoft to integrate Project Portola to fix all the issues, to bring that code into main OpenJDK repository. And we successfully delivered the job during JDK 16 release. So for two releases, for two major releases, it is there, and it now is included in the long-term supported 17 release in the source base. But well, the story lasted for a longer time. We have been providing such binaries for a couple of years, built from a Portola branch. And it originally started by Oracle, by the way, with many significant contributions there. But new port, to have it the same bar of quality as the rest of OpenJDK, required mandatory steps like providing the way for anyone to easily build it or to learn how to do it, to have a cross build for not musl environments, which is really convenient for all the developers. Of course, some testing approaches, documenting on that. Well, we have some nice consequences. Like then we use JNI. We also probably would prefer making a cross build for musl. So if you take your JNI binary part, native part as is, it may not work. So in this example, I show how to perform regular compilation, right? So we have some nice hello world implementation saying hello in native code, and then we assemble it and try to run it. Surprisingly, it works in all the environments, like my local Linux installation, which is glibc based, Alpine, not musl, which has a glibc compatibility layer, and Alpine musl, well, because we were lucky. But then we do the reverse. For example, the same easiest example, but we cross-build for musl. So we take the cross tool chain mentioned in the OpenJDK documentation, perform compilation of binary for musl environment on our glibc environment. Then it's runnable fine in Alpine musl environment. Here is an example. Then we start the container and start use that Java program, this JNI there. It's runnable in a musl environment with glibc layer, where it has that basic musl layer, of course. But then we try to run it in a pure glibc environment. It won't run, right? Because it's compiled for musl. And the binary compile for glibc will, in most cases, also fail just like that. So other interesting issues discovered during that work are, for example, the way LD preload works, and it's different on musl, so be aware of it. Alpine Linux is not unique here because for AIX operating system has its own way too, how LD preload is resolved. And other things are related to security issues introduced in previous Alpine versions, like Pax NGR security in kernel used to be enabled by default. It's not the case anymore, but we have to support the case when we run an Alpine environment, and it is old enough to have that issue. So we have to report that carefully. The JVM won't work, it will close itself, but it's better than being closed by operating system silently. There was some network configuration issues, and also debugging of the JVM itself is slightly different in musl environment. If you're a JDK developer, be aware of it. The outcome binaries, they do have their own peculiarities. Like if you run in headless mode and do some off-screen rendering, it won't probably work out of the box because you'll need to install additional packages like FreeType and fonts you need. If you really like running containers or Alpine Linux or with some NUMA hardware, well, it's better to install libnuma. The latest version is preferred here, and also to use native memory tracking, which is extremely useful to estimate the size of memory for your container. You will need the latest Alpine Linux. So, as I mentioned, Busybox sometimes performs strange, but that's because it only corresponds to a standard. So sometimes you may miss the flag, for example. Don't forget to put shebangs in your scripts. We'll look at the simplest example. And serviceability agent, again, we'll look at it right now. So for shebang, imagine you have a very simple shell script and you expect that it will be runnable if you just exec it from Java environment. Well, it may be not because you missed the shebang. So that hash, exclamation mark, and the exact shell that should execute your script, right? If you denote that, it will work. For variables, you know that dots are evil, so you may be hit by having only the first part of your variable name before dot, but that's not the problem unique for Alpine environment. For example, in Debian, you may have an empty variable instead. So the solution is provided by Spring, actually, that successfully manages underscores and dots for us. So just use underscores. Serviceability agent used to be able to work with almost that application instance. So if it's not responsible, but you could still use forced flags to work with it. But and as you see in Alpine musl environment, there is no such flag for JDK 8. If you use JDK build for glibc and Alpine with glibc layer, which allows to run all that combined, and there is such a flag. But in any case, almost it's already had been removed in JDK 11, and it's now JDK 17 as latest LTS release. So just stop using it. Now Alpine Linux port is an upstream. Any vendor can release its binary from the same source, which is very convenient. We all fix same bugs. Don't forget that's not the only optimization technique for containers, right? There is also native image. There used to be a technology for making AOT compiled code included in JDK, but now it's not there. You can have different size relation between native image and JDK based. Native image based and JDK based container. It may be smaller or larger. There are interesting experiments I show not in this talk, but remember that you want to get thin layers in any case. And then what you can get is, of course, an instant startup, right? That's also a metric of container effectiveness. So let's summarize briefly here. Native images work with closed world assumptions, and you have to have framework support for that, like Spring Native provides, right? You'll have to use different tools. You'll have to spend time and memory for compilation. Bugs are different there. We won't touch that in detail, but just remember that any path that you choose to improve your container image has its own pitfalls. Native image, of course, sometimes gives you much smaller containers, sometimes not, but if it is, then clean deploy is very fast and updates are faster. As I mentioned, we added support during JDK 16 lifetime for musl in JDK mainline. Now it's there, leveraged for all providers in JDK 17, but still about 50% of all Java users use JDK 8. I won't say it's very sad, but it's interesting. So, well, what to do with Portola and Alpine musl support? What's about our TARDIS? Yes, you can find container images for JDK 8 and for JDK 11. And we actually worked with Microsoft to bring JDK 11 support as an official one. If we will have time until this update release will be completely frozen for such improvements. Don't forget that x86 is not the only platform. There's also 64-bit ARM, and musl is a foundation not just for Alpine Linux, but for example, OpenWRT by default now uses musl for like a few years probably. So you can use that JDK and such operating system for your embedded devices or for your small environments. That's very interesting. I will have many more on that to say, but not just for now. So when you select which way to take, remember about native image. It's always an option, but you have limitations. Then you go to a classical JVM based container. You have options how to split your business logic. Will you use a thin jar deployment or fat jar deployment? Then you have to select the flavor of your operating system environment. Will you use package manager or not? Will you use it at all? And if you will use it, which one do you prefer? Do you need glibc especially, or any C library is fine for you, or any particular musl is fine for you? Then you have options. Like for example, if you take Liberica, you have Debian-based container, CentOS-based container, you have Alpine with glibc compatibility layer, Alpine with musl layer only. You can go and select any distro-less distro, right? Provided to you by a built system. And in the end, you will have containers different in size and different in layers. So for example, if you select, if you get native image based container, you'll have very thin base, like only very basic libraries, but you'll have to redeploy all the top of the pyramid. If you select musl, then you have much smaller base OS than classical, so-called classical operating systems, right? And you can split your application into thin or fat deployment ways. Or if you select kind of well-known operating system environments, you still can get the optimized JDK in terms of size, and still you can get small containers. So, as I said today, there are multiple optimization metrics and multiple ways how to perform that optimizations. Like if we talk about size, different size reduction techniques, different base containers. Especially good here is Alpine Linux with musl C library, and now it is officially present in OpenJDK. Thank you for your attention. Please follow me on Twitter or ask your questions.
Thank you, Dmitry. Yeah, thank you for your talk, and thank you for supporting Devoxx Ukraine this year. Still in online, but hopefully next year we can meet in person in Kiev. Dear participants and Dmitry, I invite you to continue the discussion and to ask questions to Dmitry in the Q&A session rooms. So please join the Q&A session, and yeah, you can continue the live discussion there.
Yeah, let's meet there.
Yeah, thank you once again.